Okay, so solving triangles using law of cosines and law of sines. Now you'll notice on all of the first four, they tell you explicitly which one you're going to use, whether it's law of sines or law of cosines. So we have those formulas. If you don't have those formulas written down, we can refer to them here. We can flash back and forth as needed. So use the law of cosines to solve triangle ABC where side A is 2.5, side B is 5.0, and side C is 4.0. So what I need to find are the angle measures. I need measure of angle A, measure of angle B, and the measure of angle C. So we'll set up our chart. Okay, and we'll have that set up off to the side. Yes? 4.5? Okay, that's easy enough. That'll make a difference. Thank you. Okay, so what else would help us other than having the right numbers? Michael? Picture. Okay, so we sketch a triangle. Now your triangle, guys, doesn't have to be super detailed. It doesn't have to be to scale. It doesn't even have to be accurate. All it has to be is labeled. So call the angles A, B, and C. Label the opposite sides A, B, and C. Okay, put the measures where you have them. Side A is 2.5. Side B is 5.0, or simply 5. And side C is 4.5. So what we're looking for are the angles. Now there's a rule for using law of cosines to find missing angles. For using law of cosines, which angle do we want to go after first? The largest one. How do I know which one's the largest? It's opposite the largest side. Good. So the largest side here is clearly side B. So I need to find the measure of angle B. Now, if we don't remember it, we can flip back and refer. We have the law of cosines right here. Now we're looking for cosine of B instead of cosine of A. So our formula is slightly different, but it's still the same principle, same idea. So I'll have that the cosine of angle B is equal to A squared plus B squared, A squared plus C squared, minus B squared, all over 2 times A times C. Now we have all three sides, so we'll sub all three sides where they belong. And we'll have the cosine of angle B is equal to 2.5 squared plus 4.5 squared minus 5.0 squared. All over 2 times 2.5 times 4.5. Now there's one big thing that we have to keep in mind before we start pushing buttons on those calculators. This division bar, yeah, it means divide, but what else does it mean? What else do we have to remember to do here? Alex, this is somewhere where you were having a lot of trouble. What was it? Parentheses. We need parentheses around the entire top, and we need a set of parentheses around the entire bottom. But if we're really careful about what we type in, we should end up with the cosine of B is equal to 0.06 repeating. Now that's the cosine of angle B. It's not actually angle B. So what I need to do is take the inverse cosine of 0.06 repeating, and I should get that angle B is approximately equal to 86.2 degrees. Take that over to my chart. Let's see if I can make this work. Oh, guess not. That'll do. Okay, next. We only want to use the law of cosines once per triangle because once we have one of those angles, we can find the other two using law of sines. Law of sines is a lot neater, a lot simpler, a lot less work for us. However, just like with law of cosines, there's a trick for which one we want to go after first. With law of sines, there's an angle that we want to find first. If we're using law of sines, which angle do we want to find first? The smallest one. And how do I know which angle is going to be the smallest one? Very good. It's opposite the smallest side. So I want to find angle A. Well, if we don't remember law of sines, we can refer to it. Side A over sine of A is equal to B over sine of B is equal to C over sine of C. Well, I have angle inside B, so that's the one that I'm going to use. Now we can also flip it, and we can have sine of angle A over the length of A is equal to the sine of B over the length of side B. Sub in the pieces that we have, and we'll have the sine of angle A over 2.5 is equal to the sine of 86.2 degrees divided by 5. Okay, then the quick thing to do, multiply both sides by 2.5, and we'll have that the sine of A is equal to 2.5 times the sine of 86.2 degrees all over 5. Okay, which would be about 0.498. Now, if you got different numbers, there's a really good chance your calculator is in radian mode. Make absolutely certain that the calculator is in degree mode. You should have a little DEG at the bottom right of the screen. If it's not DEG, push the DRG button, make it say DEG. Okay, now, again, this is sine of A. We want the actual angle itself, so we'll have to take the inverse sine, and we'll have A is equal to the inverse sine of 0.498, which gives us that the measure of angle A is approximately 29.9 degrees. Now, we can use law of sines again to find angle C, or we can use a simple fact about triangles that their angle measures have to add up to 180 degrees. So just take 180 degrees, subtract the other two, 86.2 and 29.9, and we'll get that last angle measure, angle C, is about 63.9 degrees.